Yo, what's going on, gang? How are y'all doing, mate? Welcome back, Brev. Ishak, bunking off the last lesson and pram it. It's not looking good, mate. It's not looking good. It's not looking good, mate. Yo, Carl, what you saying? Nah, I came so late. Did you? Oh, the chat was moving then. You couldn't see it. I couldn't see it. Hey, Halima, what's up? Welcome back. Basque, what you saying? Rohan, what you saying? Ayan, what's up? Kaitan, what's up? Abdul, what's going on? Yo, Ishat, we all ready to do some more radians and that. Tristan, yo. Finn, yo. Priscilla, what's up? Yo. Armino, you're violating. Yasir, what's up? Swaro, what are you telling me? Ruway, what's up? Abdul, welcome back, dude. Morning, Lungang, Ruben. Michael, what are you saying? I thought I said Michael Arteta for a second. So, what? Guys, we did radians last lesson. I'm going to show you guys how we solve trig in radians. Yeah. It's actually very simple. You just need to know some basic rules. There's a very common saying that I make. Yo, Samir. There's a, what is it? What was I saying? Yeah, there's a common thing that I say a lot, especially on TikTok, about the way we solve trig equations. So hopefully you don't do that way. Hopefully you guys don't do that way, but I'll correct you in it even if you do. What's up, Jayla? Welcome to the streams. Darko, what you saying? Ayo, Lucy. No, you're not. So, from last lesson, what did we say? We did the conversions in radians, right? 180 degrees is equal to what in radians? And then I'll introduce myself again for all the newbies. Is on. What are you saying? Day 2 and now. Let's go. Yo, Liam. Miriam, what's up? Caesar, I'm from the oldest Great Britain ally. Do you know where I'm from? I'm from the oldest Great Britain ally. I don't know. Caesar Silva. Sounds Portuguese. Hi, good. So, we learned last lesson that 180 degrees is equivalent to pi. Yeah? Hey, smile. Cool. It is Portugal. History lesson. Hey, I said Portugal. I'm right, aren't I? Now, if you're new, just a quick intro about myself. If you've seen me before, you might see that I just seem like a maths TikToker. But I'm a fully qualified teacher. I have over 8 years of teaching experience. And I did a maths degree from UCL getting a first class. So it's my job to turn you guys into absolute maths monsters as well, innit? So that's the goal. That's the goal. And we're going to use last lesson where I introduced you to radians to solve trig. I'm the subway girl. What? Oh, nah, Premit, you're violating. So, guys, let me tell you one thing, yeah? Solving in year 13, solving trigonometry in year 13 is actually just as easy as year 12. It's not that difficult, yeah? It's not that difficult. You're going to apply the same rules as year 12. There's nothing different. I'm going to introduce to you a new set of, not today, but I'll introduce to you a new set of trig functions. But they can all be converted into year 12 functions, and then there's nothing new, yeah? So everything is the same as year 12. We just have to apply our rules to radians. So, really, you guys should be leading this. Good, because I'm bad at both. Yo, Samir, what is this? So let's solve for x being between 0 and pi. Now, remember what I said last lesson. When you start solving in radians, you're going to be thinking in degrees first, and then you're going to be converting to radians. So 0 pi, at the beginning, we're going to be thinking of it as between 0 and 180 degrees. Yeah, so this is what you're doing. Yeah. Instinctually and that. Now, if you saw this equation in year 12, what would you do first? What would you do first if you had to solve 1 minus 3 sine 4x minus pi over 4 is minus uno in year 12? No, Liam, you wouldn't cry. Panic. Nah, special. What? Is on, you would add the 1. What do you mean add the 1? Kai, addition formula, that's 2. You could if you wanted to. This actually, no, you wouldn't, because then you introduce sine cos. And we haven't seen the addition rule just yet. Darker, yes, we are going to be able to do that. Pramit, good, thank you. Pramit's finally on a good roll. So we're not solving quadratic, so we don't need to make it equal 0. Like all trig, guys, you just need to rearrange for the trig function. So here, we're going to rearrange for sine. Yeah? Exactly. So all we need to do is rearrange for sine. We have, it's just like rearranging for x. You just need to put it in one place. Yeah? Now, the way we do that is first, I don't like people saying, take this 1 over. Yeah? Guys, this sign is negative, right? It's a minus 3. So whenever you solve, these are very common mistakes that students make. When you solve, yeah, for a negative variable, you should make that positive. Yeah? Rayhan, what's up on that talk Wi-Fi and that? So that minus 3, let's move it to the other side to become 3 sine 4x minus pi over 4. And at the same time, that minus 1 can add 1 over to the other side, become 2. And then we're dividing by 3. Yeah, so we have 2/3. Actually, let's write the sign on the left. So we have 2/3, we're dividing by 3, is sine 4x minus pi over 4. Afaf, we are solving for x, it's just you have to solve for sine first, because it's sine of a function of x, right? Okay, now that we've done that, what's the next most important step? Once you've rearranged for the trig function, what should you be doing next? Let's see who remembers from year 12. So Rohan, we don't inverse sine just yet. Darker, we don't arc sine. Carla, be careful because expanding doesn't actually work with trig functions, yeah? Because it's not commutative like expanding in the x, yeah? Sophie, change limits. What do you mean by that? I think you're saying the correct thing. It's just the wording. So guys, look at what Sophie said. She said change the limits. What do you think she means by that? So Sophie said change the limits. Hey, yo, Pramit, you're slacking right now. All my old students a bit slacking right now. Do you have to do something with it? Emanuela, to do with the domain. Essentially, yes. Arminor, essentially, yes. Fix up the range. Yeah? Guys, can you see the range is for 0 and pi? You modify the range. So that's what I say. You modify the range. You MR. Okay? So the range is for x being between 0 and pi. But that is only if the angle is x. Our angle is 4x minus pi over 4. Yeah? So we can very easily change it. All you need to do is manipulate it so that in the middle, it says 4x minus pi over 4. Yeah? And the simplest way to do that is you take the endpoints and you just sub it into here. So when you sub in 0, you get minus pi over 4. Then you would have 4x minus pi over 4. And then you just sub in pi into here. What is that? 4 pi minus pi over 4. What's that? 4 pi minus pi over 4. 15 pi over 4? Correct me if I'm wrong. Okay. This is known as our MR, our modified range. Let's put a box around it. Everything we do is relative to this. Yeah? Okay, now we can do inverse sine. You right. We're going to need our calculators. There's a couple of, I'm going to show you guys a few tricks here, which are going to be important for you to, a few tricks here which are going to help you solve things really quickly. So we're going to do inverse sine. Inverse sine. So get your calculators out. Now this is for 4x minus pi over 4. Yeah. Now you have to be in radians here. So at the top, make sure it says R. Yeah, so we're going to do inverse sine of 2/3. Now anybody who knows me knows what I'm going to do here. What am I going to end up doing here? $729. Nice, Samaya. I'm going to store it. Yeah, guys, you need to store these values to keep them accurate. 0. I'm going to do that after. Nice, though. So, guys, you need to store these values because radians, you're dealing with pi, right? So you got all these irrational numbers. Yeah, you want to keep it as accurate as possible. You want to store it. So, on my calculator, I've got the 991EX. My store button is above the 7. Yeah, Rayhan, you're not in radians, that's why. So look at my button here. It's above the 7. If you have the CW, can someone put in the chat, like, I think you have to press the option button or something. But for the EX crew, you just press STO. When you press it, can you see at the top? Look at the top of the screen. Can you see there's something appearing and disappearing? Yeah. So at the top, you see when you press store, this thing appears. Then all you need to do is press all the buttons, one of the buttons that has A, B, C, D, E, F, etc. I always do store and then press the button above it to store it as A. Yeah. And that's it. We're going to store it for later. Yeah. For CG50, you need to do a new line. You need to do answer, arrow, and then the letter of choice. Yeah. So that's how you do it with the CG50. So, for example, can you see it's hard for you to see here, but there's my CG50. Can you see here? There's the answer button. You're just gonna have to go back and rewatch how I do this. But that answer button, you're gonna press Shift, and then the answer button. You see it now has answer on the screen. Then you press this arrow here, arrow, and then you choose a letter. So I'll do A. So I'm going to do alpha A. Then you execute that. And now the letter A, alpha A, is now stored as 7. Yeah? So that's how you do it with the CG50. Okay. So you stored this as A. Don't worry, we'll practice loads of these storings. But make a note. Okay. Now, we have just done inverse sine. Who knows? No, Abdul. Otherwise, I'll tell you to do that. But definitely do not do that. Who knows? So this is known as the primary value. Who knows how to find the secondary value for sine? Who knows how to find the secondary? You can do it in degrees if you want. So like what you're used to in year 12. So darker, that's for tan. Nearly Kai. Rayhan, good. 180 minus. Or if we're doing radians, Nicholas, good, it'll be pi minus. So guys, in degrees, make a note of this. For sine, it's 180, take away the primary value. Yeah? What would it be for cosine? Okay, there we go, Liam. You guys remember, bun cast. We don't use that around here. The cast diagram is not used for solving trig. It is being taken out of context. Good. So for cos, it's 360 minus. And for tan, what is it for tan? What is it for tan? In the main year 13 course, I'll show you guys where we actually use the cast diagram. Sorry, Faria. It's not your fault. It's not your fault. So for tan, it's 180 plus. Yeah, it can't be 180 minus. That's sine. 3 very simple rules that you just need to... When I say remember, guys, you'll do so many questions that you don't even need to worry about remembering it. Yeah? So, in radians, all you need to do is just remember that 180 is the same as pi, 360 is 2 pi, and again, 180 is pi. So in radians, guys, it's very simple. All you need to do is just remember the degrees version. So for radians, sine would be pi minus the primary. Cos will be 2 pi minus the primary, and tan will be pi plus. So you can see the rules are exactly the same, right? The rules are exactly the same as year 12. You just need to know the conversions. That is it. Yeah. So here, remember, this is our primary value. We're going to do pi minus the primary value. Yeah. So you have your calculator screen. You're going to do shift pi minus answer. And now here, guys, we are going to store it. Yoism. Remember how much of an ache it was at the beginning, though, you guys. Okay, so let's store it. So I'm going to store it. So practice storing is B. Yeah? So write all those numbers. Store is B. 2.41186 ... Now that's known as our secondary value. We've stored it as B. Yeah? Now, Izam, we'll do that later. Do that later. I'm going to show you guys how we rearrange. Yeah? We're going to rearrange all of it later really quickly because we've stored the values. Yeah? Now, the thing is, 0.729 and the 2.411, etc. It's a lot harder to tell if it's inside the range or not because we have 15 pi over 4. Like, we can't really tell. Yeah, it's not as easy to tell as in degrees. So something very simple that we do is that minus pi over 4 and the 15 pi over 4, we decimalize them so that we can see whether we're in the range or not. So let's do that. So minus pi over 4. Obviously, we know it's these two values are going to be in the range in terms of it being negative, but let's just make a note. So this here is minus 0.785. And this, let's type that in just so we can see if things are in the range. Whoops. 15 pi over 4. So about 11.78. So both of those values are in the range. Yeah. Okay. It will happen, Ism. Don't worry. So both of these are in the range. So we have two solutions for sure. Now, who remembers from year 12 how you find the other values in the range? So how do you do it in degrees? How would you guys do it in degrees? So once you've done primary value, secondary value, how do you find the other solutions? Ruwei, good. And that would be in radians. Manuela, good. QWERTY, good. Andy, good. Add minus 360, yeah? And Irena, yeah, you could say adding and minusing by the period, which would always be 360 degrees because we have modified the range, yeah? So guys, because we've always modified the range, it's plus or minus 360, yeah? So in degrees, you'd be, so after, you plus or minus 360 degrees or plus or minus 2 pi, yeah? And the way to kind of tell if it's worth it is, guys, we're going to be a bit like engineers for a second. An engineer would say pi is 3. So we're going to adopt that strategy, yeah? And we're going to say 2 pi is about 6, yeah? So to both of these values, yeah, both of these values, we're going to add about 6. Here's the end of my range. Adding 6 kind of makes sense, right? Okay, so to both of these values, Rara, because the graphs all cycle every 360 degrees. So what we're going to do is we're going to write this. We're going to say we're going to take our primary value and we're going to add 2 pi. Now, this is why we store the values. Yeah, so go back to your calculator. We're going to do alpha. We're going to get our old solution, or A, and we're going to add 2 pi. Yeah, can you see that's in the range? Now, before you do anything, store that value. Store it as C. Okay, write it down. And then write it down. So we have 7.0129 ... Now, this doesn't actually have a name. We're just going to write C. Now, to B, we're going to do the same thing. This is why we store the values, guys. Yeah, it's going to make your lives a lot simpler. So we're going to do alpha B plus 2 pi. Boom. You can see that's in the range. Okay, so that's 8.695 ... And we're going to call that D. Store is D. Now, what do you guys recommend? Should we keep adding 2 pi? What do you think? Should we keep adding 2 pi? I mean, you can always check. Yeah? Ruwei saying no. Ishak no. Kaitan no. I agree. Like, look, the largest part of the range is like 11 or 12. If you take C and you add 6, it's at least 13, right? Exactly. It's going to go above. So I'm good with this. Now, let me show you guys something. This is how we rearrange for our answer super quick. Look at this. So look at this. So Sienna, now we're going to add pi over 4. So look at this. Now to A, B, C, and D, we're going to be adding pi over 4. Yeah, we're going to be adding that pi over 4. And then we're going to be dividing by 4. Yeah. Now look at my calculator screen. Look at this. So we're going to do A plus pi over 4 divided by 4. There's my answer. And then all you're going to do is change A to B. And then you're going to change it to C and then to D. And this is how you get the answers super quick. So you have 0. Let's just say 38. Then you change A to B. Boom. There you go. 0.80. Way quicker than you guys writing down loads of numbers. Then C. Oops, not shift. 1.95. So guys, everything I'm showing you is how a professional does these questions, isn't it? No time wasting. 2.37. 2.37. And there you go. And here, there's no loss of accuracy because you've stored the values, right? So because you've stored, what I've got on my screen is the most accurate answer you can get. Yeah. And it saves you a ton of time here. So this question here, I have done to just show you guys, what is it? The practice of the storing method. Yeah. 4x is quite a large range. But to be fair, it's quite standard. Something like this. It's not a difficult question. Nothing that we did was hard here, right? We just modified the range, stored values, and rearranged, right? We just checked, added minus 2 pi in that. Come on, let's go. What do you do after for tan? Same thing. It's all the same, guys. Primary, secondary value, added minus 2 pi. That's all it is. Yeah? Sinner, why did I do the last step? To rearrange for x. Those A, B, C's, and D's were for 4x minus pi over 4. Then we rearrange for x. Why is this making me look forward to going back to 6th form? Ayo, Sienna, you should be looking forward to going back into 6th form, innit? Come on. All right. Proofs. Guys, don't forget proofs. Prove that cos minus tan squared plus sine plus 1 squared is equivalent to that. Okay, so how would you guys do those proofs? AF, because you're doing the primary and secondary value. So even for tan, it's still primary, secondary, and then you do plus or minus 360. It is Ruben, but you're not listening to what I said. I said primary, secondary, plus or minus 360. It's the same for every single graph. It doesn't matter that tan has a period of 180. That's why for secondary value, you do 180 plus. Okay, so we expand. So we have cos x minus tan x. Cos x minus tan x. Okay. We have cos times cos. Cos squared. What's cos times tan? There's different ways you can write this down. But think about it. What's cos times tan? Nice, darker. So 0, you can write like that. Carla, good. So it's one of those where when you're expanding, I'd be thinking cos times tan. I know tan is sine over cos, right? So you can write cos tan and then simplify it after. I'd rather simplify it now. So think about it. Cos tan is the same as cos And then tan is sine over cos. Cancel. We're left with sine. Yeah? So, cos x times minus tan x is minus sine x. Yeah, and then here, we get another minus sine x. Okay? Then finally, we have this. We have, what is it? Plus tan squared. Plus tan squared x. And I guess that's it, right? I mean, oh, well, not really. So we have cos squared x minus 2 sine x plus tan squared x. Okay. Then we have sine x plus 1. I mean, you guys should also know how to... we're not doing those trig identities just yet. So don't... Just as advice for the future, don't force any identities unless it's really necessary. Yeah, but that is a true state. The 1 should be on the other side as well. 1 plus tan squared is sec squared. Yeah. So the way we square, we're going to sine squared this. You multiply these together, you get sine x. You double it, 2 sine x. And then we have 1 squared, which is just 1. Okay. Now we're just adding them together. Yeah. So now we're adding them together. So we have cos squared x minus 2 sine x plus tan squared x. Then we have the second expression, sine squared x plus 2 sine x plus 1. And then we notice, well, we should hopefully notice that the 2 sine x's cancel. What else do you notice? Not yet, darker. We don't need to change anything just yet. Halima, look up here. Nice, Pramit. So cos squared plus sine squared is 1. So nothing needs to be changed. You just know sine squared plus cos squared is 1. Which really you should write down. You don't need to write down that identity. I'm trying not to sneeze right now. So we have 1 plus tan squared plus the 1 at the end. And then we're proved. Nice one, dive. All right. Sneeze, bro. It's good for you. What? Is it? Release that bacteria, Omar. What is this? I ain't got no bacteria. Hence, find in terms of pi, the values of x between 0 and 2 pi, such that that is 3. All right, so what are we saying here? What's going on here, mate? Do you have to write QED? No, Kai. You don't need to write QED. I mean, in exams, I used to write proved. But yeah, you don't need to write QED. Extinguish the fungus. I thought we weren't allowed to do the cos squared plus sine squared is 1. What do you mean, Carla? Not allowed? So what I said was, if you're talking about what I said about the 1 plus tan squared, I said don't force any substitutions unless it's needed. So here, cos squared plus sine squared appeared, and we noticed that that's 1. We didn't force any substitutions here. We just noticed an identity. We noticed that this is equal to 1, yeah? So we didn't force any substitutions. A forced substitution would be changing cos squared into 1 minus sine squared, even though it does simplify to 1 again. But here you can just directly use the fact that cos squared plus sine squared is 1. And then Pramit and Abdul, good. So guys, whenever it says hence means you're using the previous part. Hence, this is the same as this. Yeah, I got my answer in an answer wrong because I should have used instead of I'm not sure I understand, Carla. Cos x plus sine x doesn't equal anything. Cos squared plus sine squared does, but not cos plus sine. Yeah, like I got my answer. Carla, take your time, write your question, your situation properly, and I'll be able to answer it. Yeah, so we have 2 plus tan squared x is 3. Okay. We're going to minus 2. So we get tan squared x is uno. Then what do we do? How do we deal with this situation? Situation. Root and d, yes. Now, when we square root, Abdul, good. So guys, and Frank, good. We're going to get plus or minus. Yeah, so guys, be careful. When you square root, you're going to get the positive version and you're going to get the negative version. Yeah, keep in mind the interval. We don't need to modify the range here. Remember guys, 2 pi, about 360. I'm going to show you guys some more tricks. Now, as you guys get good at this, you'll know what inverse tan of 1 is, but can you guys type in the calculator just to get a good feel for that? So how do we, what do you get when you do inverse tan of 1? Just make sure you guys know how to type things in the calculator properly. Darker, 90. Your calculator should never give you 90 when dealing with tan. Kaitan, yeah, pi over 4. I see pi quarters. Okay, pi quarters, sure. Yeah, that's our primary value. Yeah. From memory, how do you work out the secondary value for tan? What was that? Samir, no. So I'll show you guys how to deal with that -1 in a second. Okay, so 180 plus, which when dealing with radians, we're then going to do pi plus. Okay, pi plus pi over 4 is 5 pi over 4. Secondary value. Now let me show you guys another trick. That range, it's still quite difficult. Well, it's not that difficult, but it's still not as easy to see if pi over 4 and 5 pi over 4 are within that range. Yeah? Carla, I'll come back to your question, yeah? If I can change the range so that it's over 4, it's easy to then compare. So 0 is just 0. But 2, how would you write that so that its denominator is 4? How would it change? How can you rewrite 2 so that it has a denominator of 4? What would it look like? Eight over 4, good. So 2 is 8 over 4. Now, from here, you can easily see that 5 pi over 4 is within the range, right? Yeah, because 5 pi is less than 8 pi. It's much easier to compare than comparing 5 pi over 4 with 2. Yeah, so always look out for stuff like that. So both of them are definitely in the range. Now, inverse tan of -1, that should give you minus pi over 4, which is your primary value. Now, that definitely is not in the range. These two are. That is definitely not in the range. But guys, we keep doing what we're usually used to. We're going to do pi plus that value, which will look like this. So we're still doing the exact same thing. That would be what? 3 pi over 4. Then what do we do? Which is our secondary value, which when you compare it to the range is in the range. Do any of you guys know what we need to do here? No, Jayla. So like here, you're seeing the primary value is not in the range. Afaf to what? To what? So add 2 pi to which value? Add 2 pi to which value? The PV or SV? To the PV or SV? Not the SV. The SV's rate is going to be too big. If you add 2 pi to this, it's going to be way too big. Afaf and Sienna, good. It's the PV. Guys, that secondary value, you could try it. Yeah, if you do 3/4 plus 2, like if you do in your calculator, if you do 3/4 plus 2, 11 over 4. So it's too big. Yeah, it's too big. You should always really be starting with the primary value. So doing minus pi over 4. So just because a value is not in the range doesn't mean you ignore it. You still use it to find other values in the range. So when you add 2 pi, 7 pi over 4. There you go. And you can see that's less than 8 pi, right? So we're going to do our primary value plus 2 pi, which is 7 pi over 4, which is now in the range. And there we go. We have 4 answers. We didn't need to modify the range here, so we had pi over 4, 5 pi over 4, 3 pi over 4, and 7 pi over 4. 4 answers. Yeah? And really, guys, we're using the same techniques as year 12. It's just we're working in radians. That's it. Tristan, cold. Oh, wait, hold on. What was... Basically, I got my answer in an exam wrong because we have to solve a trig equation. And I used sine squared plus cos squared is 1 to change cos squared to a sine value. But apparently I got it wrong because I had to use cos x plus sine x is 1. Carla, whoever's told you sine x plus cos x is 1 needs to get sacked. Because sine x plus cos x does not equal 1. Yeah? So, you shouldn't have got that wrong. It depends on the question. But at no instant is this true. Yeah? That is not true. Sin x plus cos x does not equal 1. Yeah? Yeah. Just be careful of that. You'll sack me. That's a scam. Yeah? Okay. Sin x plus cos x doesn't have a value. I mean, we could solve it. We could solve sin x plus cos x is 1. But, I mean, x is 0 works here. If you sub in 0, you'd get a solution. I think multiples of 2 pi. So 0, 2 pi, 4 pi, all of these work. But they're specific. But sine squared plus cos squared is 1 for any value of x. Yeah, any value of x you substitute in, you will always get 1. Yeah, it's quite cool to be fair. So like if you get your calculator, so like look, if I do this really random number, yeah, I'm just going to store as a. If I do, you have to type in like this, sine angle squared plus cos angle squared 1. It's pretty cool, right? And also you can change this value. So look, if I press calc, I can just do a really, whoops, not like that. If I do a really random number, look, I'm just pressing all these. Yeah, and then I just press equals, it's still 1. Yeah? But that's not the case for sin x plus cos x. It's going to give random numbers. Yeah? All good, Omar. All good. Okay. Next one. Show that the equation 5 cos x plus 1 is sin x tan x can be written like that. All right, what would you guys do first? Yeah, by the way, I'm not a professor. I'm just a maths nerd. I was done with uni once I'd finished. Grace, type in the calculator. You're just doing 1 plus a quarter, right? NJ, that'll be for the next one. But yeah, good guys. So we're going to change tan into sine over cos. So we have 5 cos x plus 1 is sine x. And tan is sine over cos. Okay. And then what happens here? This guy boogieing. What ends up happening now? Sines don't cancel, but what happens? Yes, 0. So it becomes sine squared. And then we'll multiply through by cos. So the first thing we should do is rewrite it so that it's sine squared. And then over cos x. And then we multiply through by cos. So times this by cos x. Then here we have 2 terms, right? So we have 5 cos squared plus cos. And then this cancels, sine squared. Okay, then what do we do? Now we turn sine squared into 1 minus cos. Now, the way you decide, even if I didn't give this to you guys, you would know to do that. Yeah? Because it's to do with this. This cos x is linear. It's singular. There's no squared there. Meaning you can't manipulate the cos. Yeah, there's nothing to do there. That is fixed. So it's the sine squared that needs to change. So we get 5 cos squared plus cos x. We know sine squared plus cos squared is 1. So sine squared is 1 minus cos squared. And we're going to move everything to this side. So we add the cos squared, we get 6 cos squared. We have the cos x here. And this positive 1 on the other side is minus 1 is 0. Okay. Then you can just double check. Yeah, there we go. Hence meaning use part A. Solve this equation. What's happening here? How is this related to part A? Make a quadratic. So, yeah, so all that's happened is that, yeah, the angle is doubled, right? So it's the exact same as part A. It's just x is now 2 feta cheese. So we're literally going to write our answer from part B. We're just going to change it to 2 feta. Okay. And then we need to solve this quadratic. Any recommendations? Parmesan. AC method, this guy. Change to Y, NJ. I guess. So, ayo, brev. So we have to change. If you want to rewrite things, we can let. Exactly, we can let. Now, some of you are saying X, some of you are saying Y. I recommend you guys don't use X or Y. X we've already used in part A. And Y, I don't recommend we use just because we usually have equations written in terms of Y. Andy, yeah, we should use U, as in you don't have to. I recommend U because we're going to do integration by substitution eventually. We always use substitutions as U, yeah? So we get 6U squared plus U minus 1 is 0, yeah? But if you do Y, that's fine. X, I don't recommend you do just because we've already used X, yeah? Now here, if you want, you can use your calculator to solve it. But you have to show the factorizing. Guys, if you don't show the factorizing, you're going to get it wrong. Yeah? Well, you're going to lose marks. Let's go menu, let's solve it. Whoops. Menu, solve it. 6, 1, minus 1. So a third in that. A third. What is that? A third. And this no is on. It requires way too much preliminary knowledge. So here we're going to do our factor theorem, work backwards. So we get 3u minus 1 and 2u plus 1, yeah? Okay, so we have cos of 2 theta is a third. Don't forget we made that substitution. What do we do next? What do we do next? Wait, that's long. Ranges. So we're going to modify the range, which is between 0 and pi. We're going to double everything. 0, 2 theta, and 2 pi. This is a standard range. It's like 0 and 360, right? And now we're going to do inverse cos. Yeah? So we get 2 theta is, and remember, we're going to store our values. So inverse cos of 1/3. Store that as A, because we're going to half it later. Do not half it now. How do you work out the secondary value for cos? Is our PV. How do you work out secondary for cos? In radians. In radians. Ego. 360 minus in degrees, yeah. 2 pi minus. 2 pi minus PV. Alright, let's store that. Wait. 2 pi minus, boom, store it. These are definitely in the range because you've done 2 pi minus, right? Roblox stream. Do people... I don't even know what Roblox is. I can't lie. Now, these are both in the range, right? Because you did 2 pi minus. This is going to have to be in the range. Would you recommend we add and minus 360? Or add or minus 2 pi? Overwatch stream. I don't even have anything on this computer. I just stream maths. Neil probably plays Coco Melon on Roblox. Brave. Certified angst it. Yeah, the answer is no. Yeah, because this is about between 0 and 6, right? So if you add or minus 6, you're obviously going to come out. Yeah. All right, let's do the same thing with this. Oh, wait. Should we just divide them by 2 now? Because maybe we'll have to restore, right? So we're going to do a divided by 2. I'm happy with 2dp here. 0.62. And then change a to b. 2.53. All right, let's do it with the next one. This should be, I think, 2 pi over 3. So inverse cos of minus a half. Come on. At least this is a nice... This is a nice one. That's my primary. We do 2 pi minus that. What would that be? 4 pi over 3? And again, we're not going to add or minus 2 pi. If you edit this, guys, you would get what? 6... No. Yeah, 6 over 3 pi. And you can see 2 pi and 4 pi are within that. Yeah. So yeah, we don't need to do anything. We don't need to add or minus 2 pi. Then we just divide everything by 2. This divided by 2, you're just halving the numerator, pi over 3. Halving that, 2 pi over 3. And those are our solutions. Pretty simple. Nothing, how do I clear my stored values? You don't need to. You don't need to clear anything. You could just overwrite it. But if you do want to clear it, you just reset your calculator. Yeah. That's it. All right. Yes, mate. How would you guys solve this? Interesting question, Mike. Nice one, Dowd. Always homework, Omar. Frank, what is it? Is that what I said? 1dp. I mean, yeah. Where appropriate. All right. Is my bro's telling me off with my own question. I am the question. Fair play, fair play. At least you're reading properly. Andy, 3 tan x. Okay, I know what you mean. Guys, we don't want to expand here. We don't want to expand. Look at what Andy's doing. We did, Sophie. I am the question. Good his answer. That's what Andy was getting onto as well. Guys, I've made your lives easy. It's already factorized. So either 3 tan 2x minus 1 is 0. Ayo, Pramit, get out of it, man. This guy. 1 minus 2 cos x is 0. Yeah? Okay. So, Dylan, tanch is 1 minus cos squared. Bro said hyperbolic tan. Okay, so guys, I made your life simple. What do we do next? Maybe Amberjeet. See if you guys can beat me today. Maybe. Bro said just do what? QWERTY solve. So add 1, yeah? So rearrange for tan, yeah? So you'd get tan 2x is what? 1 over 3. And for this, you'll move the cos to the other side. So you get 1 is 2 cos x. So cos x is 1/2. Okay, then what do we do? Get Baza. Modify the range, Manera. Yes. Now, is the modification of the range applicable to both or just the first one? So when I modify that range, is it going to be for both of them or just for one of them? Only for tan, good. So guys, this cos x is a half. That does not need a modified range. So you can modify ranges for one equation at a time. Yeah, so we're going to double everything. Okay, for our modified range. What else do you think we're going to do here? What else do you think we're going to do here? That I would recommend. Let's see if you guys remember what I would recommend, especially because of what's going to happen next when we solve this. Let me see. Because it's 2x, Zakir. Afaf, good. Decimalize, good. Ruwait, we changed to a decimal. So 4 pi. So guys, it's good for you to see what that is as a decimal. So we can make some good decisions here. Yeah, so 4 pi is about 12.56. Yeah, you don't need to round anything. Just decimalize it so you can see. All right, let's do inverse tan of a third. And store it, mate. Inverse tan of 1/3. Store it, mate. Always store after. Store. How do you work out secondary value for tan? 0.32175 PVA. How do you work out secondary for tan? 180 plus or pi plus your PV. So pi plus answer. Before you write anything down, store it. What do we do next? Once you've done PVSV, what's the next step? These are both clearly in the range. Add 2 pi. Good. So we're going to do A and B, both of them. I'm going to add 2 pi to both of them. Okay, so we have A plus 2 pi. Remember, do not write anything down until you've stored it. Store it as C. I have to keep changing my mouse and all that. So that's C. Then we're going to do B plus 2 pi. Store that as D. Should we keep going? Should we keep going? Private says no. Carl says no. Ruway says no. I mean, I agree with Zakir here. So you do want to try it though. Because guys, when you're adding 6 to this, it's very close to that boundary. I recommend that you at least check. You don't need to write anything down. Just double check C plus 2 pi. Okay. That is close. Yeah, it's close, but not quite, mate. Yeah. This is why you decimalize that value. So guys, I'm giving you these tricks. They're going to save you in the long run, innit? Okay. Now, to all of these values, we're going to just divide them by 2. Okay. So you're just going to go fraction A over 2. 0.16. Then you're going to change it to B. 0.16 and this. I'll do it 2 at a time. 0.16, 1.73. Then you just change it to C. Nice, mate. 3.30, 3.30, 3.30, and this. 3.30 and this. 3.30 and 4.87. Okay? And those are all the solutions to tan of 2x equals 1/3. All right. Let's solve cos x is a half. This is going to be a nice value. I'll help you guys out. Inverse cos of a half is pi over 3. How do you work out the secondary value for cos? How do you work out the secondary value for cos? Remember this, we're doing it between x and 2 pi. So we didn't need to modify any ranges here. Is on, yeah. 2 pi minus. Good, guys. 2 pi minus. See, it's very easy to remember these rules, right? So when you do 2 pi minus a third is what? 5 pi over 4? 5 pi over 3? Yep. Now remember my trick here, guys. If you rewrite this as over 3, that'll be 6 over 3 pi. You can see both of these are in the range. Are you going to add a minus 2 pi to these values? What are you guys thinking? Yeah, I probably wouldn't. You're basically saying, look, here's 0 and 2 pi. You've just found pi over 3 and 5 pi over 3. Adding 2 pi, if the range is 2 pi, adding 2 pi is going to take you way out. Yeah, because the range is 2 pi, so it doesn't make a difference. Yeah, so there are our other two solutions. Pi over 3, 5 pi over 3. Okay. So, it's 5.23, so it's cutting too close. I guess so. I guess so. And I think that, guys, is how we solve trig in radians. So, guys, it's not very difficult, right? I've shown you guys the tricks, mate. Now you guys should be experts. Now should we do a quick Kahoot? See if you guys can beat me. 3-question Kahoot. I'll put in the chat. Be aware though, when you guys do my actual year 13 main course, I don't play Kahoot because we don't have time. But here we have a bit more time. Finn, I'll be doing the full year 13 curriculum. My full course starts in September. I mean, if you guys want to sign up early, you can do. But yeah, Abdul's upset that we're not going to have time for Kahoot in year 13. No is on. Alright, let me join. Nice one, Aisha. It's gonna be lit. Neil. Okay, you guys, the top grades and that. I'm in. I don't have it on hand, but if you guys are interested, in the description, can you see there's a number? If you guys contact that number, say you're coming from the summer school and that you want the early bird discount, my team will be able to sort you out. Yeah. So there's a number in the description. If you just go in there and just say you're here for this, you're in the summer school and you want the early bird discount for year 13, my team will be able to sort you out in it. What are differential equations and are we doing it in year 13? Differential equations is just solving using integration. Merch should be the prize. Andy, we do have referral scheme. Sienna, I don't have the information. Just message that number in the description. Okay. We got like 30 seconds, you lot. I see. Do unis care about your AS grades? Not unless you did an official exam. Okay. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Let's go. Oh, wait. Am I going to need my calculator? I'm not sure. I don't like using the graphical one. Wait, let me get my other calculator on deck. 3 questions. Okay. Double points. What is your name, Pramit? Neil does mistakes or something? Yes, mate. All right. True. Who said false? Unbelievable. 1 minus sine squared is cos squared. Sine squared plus cos squared is 1. Come on, mate. Cotangent. Cot, you know. Darker on top. Me and Dowd equal on points. All right, let's go, mate. Question 2. Double points. Find the area of the sector which has radius 6 and... Oh, no. I'm not allowed to use a calculator. Okay. I was slow, mate. Slow. Guessing. It's not looking good, mate. I'm in 7th place now. Nah. Luffy. I'm 46 points behind. So half r squared theta. Half r squared. 6 squared is 36. Half of that is 18 times theta. 18 times 3 over 4 is 27 over 2. And then don't forget your pi, mate. Oh, it's all changed. QWERTY's now on top. All right, final one. Final one. Let's see. Mate, Dom, they're all double points. Solve cos x is... No. Okay, I need my... Mate. How are you guys getting answers already? You guys are just cheating. Oh, wait, did I do the wrong one? Oh, no. I think... Wait. Did I press the wrong one? I pressed the solution based on the secondary. Oh, I got it. I'm on the podium. Alright, so here's your working. So inverse cos of 0.75 is 0.723. So it's between blue and red. Then you do 2 pi minus, you get 5.56. Okay. Let's see. Oh, mate. That's so annoying. Zam. In first place. Game's rigged. Hi. Who's hi? Hey, yo, what is this? And Sienna. And A. A or W's for hi. Whoever that is. But anyway, guys, remember there's homework, which you can use to practice more. And yeah, if you are interested in a full course, then the number in the description, you just message that, say you want the early bird, or you're interested, you want the early bird discount and that. But otherwise, guys, I'll see you next, what is it? Next Monday. Yeah? Well done, you lot. Neil got smoked. I came third. I won the last one, innit? Don't watch that. Cheers, guys. Hopefully it was valuable to you. The game's the game. I'll see you all next week. Have a good rest of your week, guys. Peace out. Nice one.